Hello guys, welcome again. So today we are going to be looking at data representation. We are specifically going to look at stem and leaf diagrams and box and whisker plots. So I have this question here. It says 6 teams of 15 runners took part in a charity run last Saturday. The times taken in minutes to complete the course by the runners from the Falcons and the runners from the Kites are shown in the table. So you have this table here with all the data. And then they want you to draw a back-to-back stem and leaf diagram to represent this information with Falcons on the left-hand side. So they specifically say that the Falcons must be on the left-hand side. You must follow instructions. So then we'll draw our stem and leaf diagram here, and I will have my Falcons on the left-hand side, and then I'll have the Kites on the right-hand side. Looking at the data, you see that the data starts from 30 going up to 70. So that means my stem should have 3, 4, 5, 6, and 7. I'm going to enter the data for Kites first. The data is already sorted. It's in ascending order, so we're good. So if I look at Kites, I have 32, so then I'll write 2. Then I have 2 40s, then I'll write 0, 0. Notice that I've lined up the 2 and the 0. You need to have nice columns. Otherwise, this is penalized by Cambridge if you don't have columns. Then you have 45, you have 47, 48. Then we'll go to 52, 54, 58, 59, and 59. Then I have 60, 61, 63, and 65. So just count the leaves, make sure they are 15 so that you know you didn't miss a value. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that means I've entered all my values. Filling in the data for Falcons, I have 38 and 39. And then I go to 42, 44, 46, 48. And then I go to 50, 51, 52, 56, 58. And then I also have 59. Then I go to 60s, I have 64. I have 69. And then I have 76. So count the leaves, make sure they are 15 again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we have entered all our values. Now you need to write a key for your data, for your stem and leaf. So I'm going to write here key. Then I can just take the where it says 2, 4, 0. So this means 42 minutes. 42 minutes for the Falcons. And 40 minutes for the Kites. Okay, so we are done with this one. We move on to the next question. It says, find the median and the interquartile range of the times for the Falcons. So we want the median, we want the interquartile range. So that means in my calculations, I'm going to need Q1, I'm going to need Q2, I'm going to need Q3. Q1 is a quarter of n. That means it's 15 over 4. 15 over 4, 15 divided by 4 is 3.75. So because it's a decimal, I take the next value, the n plus 1 value, which is the fourth value. Okay, then I need my median, which is going to be half of 15. Half of 15 is 7.5. Therefore, I take the eighth value. And then I have 3/4 of 15, which will give me 11.25, which is the 12th value. Okay, so you can just say then your median is equal to, you go and count until the 8th value for the Falcons. So we are going to say 1, 2, 3, 4, 5, 6, 7, 8. So that will be 51. So your median is 51. So I'll say my median is 51 minutes. And then for the IQR, the interquartile range, you are going to say it will be equal to Q3 minus Q1. Q3 is your 12th value. So if this was 8, then I continue 9, 10, 11, 12. That will be 59th value. That will be 59. So this is going to be equal to 59 minus the fourth value is 44. Then I subtract 44. And if I subtract this, I should get my interquartile range equal to 15. You are done with this question, you move on to the next question. Okay. So our next question says the Lions and the Tigers are two basketball clubs. The heights in centimeters of the 11 players in each of their first team squads are given in the table. So you have this table. Just check again if the data is arranged in order. You can see that the data is not arranged in order. I have 186 coming before 181. You need to sort that data. Okay, so we will have to sort out the data and then draw a back-to-back stem and leaf diagram. You have also been told that the lions must be on the left-hand side, so follow instructions. Okay, so then I will have the lions on the left-hand side, so lions, and then I will have the tigers on the right-hand side. If I look at this data, it's starting from, let me just look for the smallest number here. The smallest number is 160. Yeah, it's in the 160s. It's 169. So my stem will start from 16. Then I'll say 17. Then I'll say 18, 19, 20. Because I have 201 there. So I need to end at 20. So filling in the stems, the leaves for the tigers, I need to start with the smallest value. So the smallest value is for the tigers. Remember, you need to sort your data. So my smallest value is 179. Okay, so then I write 9. And then after 179, you have 180. So then there's 180. So we write 0. Then we have 183. Then we write 3. Make sure again that your numbers are nicely lined up in columns. Then after that, we have 184, which is this one. And then I have 187. So I'm still on the 18 stem. After 187, you have 190. So then I have 190. Then you go to 191, 194, 195. Then we have 197. And then finally, I have 201. So let's just confirm that we have all of them. So we have 11. So count these leaves. There must be 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have entered all the values. Now we need to enter the values for the lions, starting with the smallest value. The smallest value is 178. Okay, so I'll start, is that the smallest value? No, there's 169. So I start with 169, I write 169. So that is this value. Then I go to 179, 170s. So in the 170s, I have 178. So I write 8 nicely in columns. And then I have 179. So then I write 9. After 179, you go to the 80s, 186. And then I have 187. And then I have 189. Okay. Then after that, you have 190. 180, we have entered that. Then I have 190, which is here. And then I have 190 again. And then I have 196, so ending here. So just make sure that you line things up nicely in columns. So this 6, I'll place it nice and perfect with the 6 above. So count the number of leaves. There must be 11 again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have entered all the data again. So we can write our key. The key is that if I take 8, 17, 9, this means, what was the data about? This is the height. This means 178 centimeters for the lions. And it also means 179 centimeters for the tigers. Okay, so then after that, you are required to find the median and the interquartile range for the heights of the lions' first team. Okay, so for the lions, which means on the left, once again, I need Q1, I need Q2, I need Q3. And I have 11, so 11 divided by 4 11 divided by 4, that gives me 2.5. So I have 11 over 4, which gives me 2.5. That means I need the third value. Then with Q2, I have 11 over 2. So this is 11 over 2, which will give me 5.5, which is the 60 value. And then 3/4 of 11 is going to be equal to 3/4 of 11 is 8.25. 3/4 of 11 is 8.25, which means this is going to be the 9th value. So I can just write here that my median is going to be equal to the 6th value for the lions. So I count 1, 2, 3, 4, 5, 6, which is 186, 186. So this will be equal to 186 centimeters. And then my IQR is going to be equal to Q3 minus Q1. Q3 is the 9th value. So if this was the 60 value, that means I have 6, 7, 8, 9. So 119. So 119 minus the third value. The third value is 179. 179. This gives me an IQR of, what is 90 minus 71? I need a calculator for that. 11. Okay. So this is your interquartile range. Okay, part C then says it is given that for the tigers, the lower quartile is 183 centimeters, the median is 190 centimeters, and the upper quartile is 195 centimeters. Make two comparisons between the heights of the players in the lion squad and the tiger squad. So if they want two comparisons, it means you must compare measures of centrality and measures of spread. So I'm going to compare the interquartile range. So if you compare the interquartile range and you compare the median as well, then you have two comparisons. So starting with the median, our median for the lions was 186. The given median for tigers is 190. So you can see 190 is greater than 186. So we can say on average, the tigers are taller than the lions. Okay, the tigers have taller players than lions. They have taller players than the lions. Okay. Okay, that's the first comparison. Okay, so for the other comparison, you can just go ahead and compare the interquartile range. So we can say here, the interquartile range for the tigers is going to be 195 minus 183. So 95 minus 83, that gives me 12. So we can say that the heights of the tigers, the heights of the tigers are much more spread out, Then you say IQR equal to 12 compared to the lions. Then you can say IQR equal to 11. We just calculated it. Okay, then we move on to the next question. The next question is a back-to-back stem and leaf diagram for showing the diameters in centimeters of 19 cylindrical pipes produced by company A and company B. Okay, so you have all this data. The key says 1353 means that the pipe diameter for company A is 0.3051. Okay, so read the key. Don't skip that part. You must read the key. You see here, we have a decimal. If you don't read the key, you end up thinking that this is 351. So they say find the median interquartile range of the pipe. So every time I see this question, I see I need median, I need interquartile range. So that means I need Q1, I need Q2, I need Q3. Then I know Q1 is a quarter of 19. So 19 over 4. So we just divide 19 divided by 4. That gives us 4.75. So we take the 5th value. Okay. And half of 19 will be equal to what? 9.5. Half of 19 equal to 9.5. So we take the 10th value. And then what is 3/4 of 19? 3/4 of 19 equal to 14.25. So we take the 15th value. Okay, so I can just conclude here that the median is equal to the 10th value, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 0.355. Please be careful. Do not write 355 here. Remember, these are decimals, so it's 0.355. And then the interquartile range, you are going to write this is Q3 minus Q1. Okay, so this will be Q3 is the 15th value. So that will be, if this is 10, that will be 11, 12, 13, 14, 15. That's 0.366. 0.366 minus the 50 value, that's 1, 2, 3, 4, 5, 0.348. 0.348. And then you just subtract these numbers, 0.366 minus 0.348. That gives you 0.018. So the interquartile range is 0.018. We are done with that question. We'll move on. It says it is given that for the pipes produced by company B, the lower quartile, the median, and the upper quartile are these values respectively. Draw a box and whisker. So draw box and whisker plots for both companies on the same grid. All right, on this same grid here. So you want a sensible scale that will accommodate your data. So you need, for you to actually do that, let me write on the side, you are going to need for company A and company B, you are going to need Q0, Q1, Q2, and Q3. So for company A, we just calculated these values. We found Q0, we didn't calculate Q0, but we can get it from the stem and leaf. So Q1 is 0.348. You can write all this in pencil. And then the median, we found it to be 0.355. And the upper quartile was 0.366. And then I need Q4 here. Okay, so Q0 and Q4 will be 0.334. That is the lowest value, 0.334. 0.334. And then my upper quartile, not the upper quartile, the maximum value, that will be 0.374. 0.374. So this one is going to be 0.374. And then you just need for company B, I just need Q0 and Q4 because the other ones are given here in the question. So Q0 for company B is 0.331. So this is going to be 0.331. And the maximum value is 0.338. 0.338. So here I'll just write it here, 0.338. Or is it 0.338 or 0.88? 0.88. Okay, that's 0.88. So just remember that. Now let's go and decide on our scale. So on the horizontal, I need a nice scale here that will accommodate all these values. Okay, so going this way, this represents diameter of the pipes measured in centimeters, right? So I want to start from around 0.3 going up to 0.39. So 0.3 up to 0.39. So 0.3 what? 0.33 up to 0.39. So I'm going to say the first one, let's say this one is 0.330. Then this one here will be 0.340. This one here will be 0.350. And here I have 0.360, 0.370, 0.380, 0.390. Okay, like so. So I have my scale, and then I can just write, let's say I want to have my company A here. Company A along this line, and maybe along, let me use maybe along this line here. Should I use this line? Maybe this one. I'll have my company B here. So company B data will be plotted here. So let's start with A. So it's 0.334. 0.334 will be here. So I can just mark here on 0.334. And then I have 0.348. 348 will be here. This is 0.348, right? Is that correct? Yes. And then I need 0.335. 0.335 will be this one right here. Okay, then I need 0.366. 0.366 will be right here. And then I need 0.374, which will be right here. Okay, so I just draw the whiskers, but connecting Q0 and Q1, and then Q3 and Q4. Okay, make sure that your whiskers do not cross into the box. So I encourage that you use a pen here so that things can be seen nicely. Okay, but use a ruler. I'm not using a ruler here, so that's why things are not looking pretty. But then draw your box up here. Just connect that. So this will be the box and whisker for company A. Then you go ahead and draw the box and whisker for company B, starting from 0.331. 0.331. 0.331 will be here. And for Q1, I want 0.346. 0.346. 0.346 will be here. And for Q2, I want 0.352. 352 will be here. And then I want Q3. Q3 is 0.370. 0.370. Oh, that means on the line, exactly. So it's going to be right here. And then Q4 is 0.388. 0.388. That will be here. That's 0.388. Okay, so then I connect, once again, I connect Q0 and Q1. Those are the whiskers. And then Q3 and Q4. Those are my whiskers. And then I draw the box, making sure your whiskers don't get into the box. So this will be the box and whisker for company B. So we are done. So make sure you label company A, company B. If you don't label company A, company B, you will be penalized. And again, make sure you take care of your scale. Make sure you have a sensible scale down there. Then they say, make one comparison between the diameters of the pipes produced by companies A and B. Okay, one comparison. So I'm going to use measures of centrality. You can use measures of spread. So you can compare the interquartile range. I'm going to compare the median. So you can see the median for company A is higher than the median for company B. Company B is 0.352, whereas company A is 0.355. Okay, so on average, company A produces wider pipes. Okay, I'm done. You can just say than company B, but I'm done. Okay, we move on to the next. The next question says the following back-to-back stem and leaf diagram should represent the monthly salaries in dollars of 27 employees at each of two companies, company A and company B. Okay, read your scale. So if I have 276, this means 2,760. So there's a zero that is not included here. So you need to add zero to whatever number you have. So they say find the median and the interquartile range of the monthly salaries each of employees in company A. So we just focused on the left side of the stem and leaf, but I need Q1, I need Q2, I need Q3. So remember, Q1 is a quarter of 27. So 27 divided by 4. So 27 divided by 4 equal to 6.75, which will be the seventh value. We take the next value if we have a decimal. And then we go 27 divided by 2, that should be what? 18.5. So we take the 14th value. So 27 divided by 2 will give me 13.5, which is the 14th value. And then I have 3/4 of 27. So 3 by 27 equal to divided by 4 equal to, then I get 20.25. So I have 3 by 27 divided by 4, which will give me 20.25, which is the 21st position. Okay. So you can just conclude here that your median is going to be equal to the 14th value for company A, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 14th value is $2,710. So this is $2,710. Okay. Remember, you must add a zero. Okay, so then the interquartile range, IQR, is going to be equal to Q3 minus Q1. So that's going to be the 21st value. So if this was 14, that means 15, 16, 17, 18, 19, 20, 21. That's 2,840. So this is 2,840 and then minus. So we subtract the seventh value. The seventh value is 1, 2, 3, 4, 5, 6, 7, 2,110. 2,610. Okay, so this is $2,610. So you are going to get your IQR is 2840 minus 2610. That gives me 230. So this will be 230. So yeah, that's that. If you want, you can just write it nice and clean. You can say the median is equal to $2,710 and the IQR is equal to 230. Okay, that's the interquartile range. Then we move on. So this question says the lower quartile, median, and upper quartile for company B are these. Oh, it's still the same question. So we are given some values for Q1. So this is Q1. I'll write Q1 here. This is Q2, and this is Q3. You are required to draw a stem and leaf diagram. So draw a stem and leaf diagram, but before you draw a stem and leaf diagram, you want to collect your information. So we already have this information. We have calculated Q1, Q2, and Q3 up here for company A. So we just need those values. Q0 and Q4 can be found on the stem and leaf diagrams. But now you want to find out what is the lowest value you have. So the lowest value I have is 2,500. So I have 2,500. That is the lowest value. Going on to 3,090. So you want to go from 2,500. Here's 2,500, this one, going on to 3,090. Remember, you add a zero. So this is 2,500. This is 3,090. So work out a scale that will accommodate values from 2,500, and you will be able to accommodate 3,090. Okay, so yeah, we can just make sure we use a sensible scale. So let me think of a scale here. What are we recording? What is our data about? These are salaries in dollars, okay? And we calculated everything. We had our, oh, I forgot to say dollars here. So this is dollars. So remember, this is in dollars. Okay, so we need on this, on the horizontal axis, I have salaries here. You can just write salaries. Okay, these are salaries measured in dollar. That is the currency. And then you need a sensible scale down here. Can I draw a perfect straight line? Okay, almost. Okay, so now if I start from, let's say, you can calculate actually, if you go from, let's say we want to go from 2,000 up to, let's say I go to 3,100 to accommodate 3,090. And then I subtract for me to accommodate 2,500. I don't want 2,500 to be exactly on my line, on the first line. So let's say I'll subtract up to 2,400. That means I have 700 units in between. But here I have 1, 2, 3, 4, 5, 6, 7 major boxes. So these boxes are enough. If I just space them, each major box to represent 100, because I have the distance is 700. Okay, so I can say that the first one is $2,400. The next one will be then $2,500. And then I have $2,600. Then I have $2,700, $2,800, $2,900. Then I have $3,000. And then I have $3,100. So I'll be able to accommodate all my data. So if I start with, let's say, let me decide where I want things to be. So company B is going to be here. Company A, I want it here. So I'm going to write here company A. And then I'm going to have my company B here. Okay, so let me just go and get the data for company A. I want Q0. Q0 is 2,500. So I just go and mark 2,500 for company A. That is 2,500. Q1 for company A, we calculated it to be 2,610. 2,610. So that means 2,610 will be right here. So I'm going to have my box here. Starting there, that's my Q1. And my median was 2,710. 2,710. So that will be here. Use a ruler, draw this nice and perfect. Okay, so Q3, what was Q3? 2,840. So then I need to draw 2,840 will be here. And what is my largest value? My largest value, Q4. Q4 is 3,010. Okay, 3,010. So I need 3,010. Is that 3,010? Yes, that's 3,010. Okay, so 3,010 will be around about right here. This is where it is. Okay, so please just draw your whiskers connecting Q4 to Q4 and Q3, then Q0 and Q1, and then you can just draw your box, use a ruler. I encourage you once more to use a pen here so that the examiner can actually see your box and whisker. Let's move to company B. I need the lowest value of company B. For company B, the lowest value is 2,540. 2,540. So 2,540 is here. So I'll just mark a line here. Then I want my Q1. Okay, Q1 is given, is 2,600. They gave it to us. So this is 2,600. Then I need 2,690. 2,690 will be right here. And then I need 2,780, 2,780. 2,780 will be right there. And then I need Q4. Q4 is the largest value, which is 3,090. So I need 3,090. 3,090 is right here. Okay, so connect Q3 to Q4. There's a very long tail, so the data is queued, okay, compared to company A. And then I have that. So this is my box and whisker for company B. So I'm done. Then it's a comment on whether the mean would be a more appropriate measure than the median for comparing the given information for the two companies. No, it won't. It's not going to be. Okay, so I'll write no. Then I need a reason. So if you look at the data, you can see that tail that I have for company B, what caused it? If you go onto your data, you can see you don't have anything in the 2,900s. You don't have anything. Your last value before 3,090 was 2,820. So 3,090 is on its own. It's kind of compared for all the data in company B. This is a highly paid individual, whereas everybody else is getting less. So there's someone who is paid exceptionally high. So this is kind of like an outlier. So we can say no, because the outlier, the possible outlier, we didn't calculate it. I didn't test it. If you wanted to test, you would test whether it's within 1.5 of the interquartile range from the upper quartile or from the lower quartile going back. So you can do that calculation to see if it's indeed an outlier. So there is, because the possible outlier, I'm going to call it the possible outlier. The possible outlier, $3,090, $3,090 salary affects the mean salaries of company B, the mean salaries of company B, but will not affect the median. So the median is the best to use, will not affect the median. The median is the best average in this case, okay? All right, so we are done with this one, and then you move on to the next question. Okay, so on this question, it says two machines, A and B, produce metal rods of a certain type. The lengths in meters of 19 rods produced by machine A and 19 rods produced by machine B are shown in the following back-to-back stem and leaf diagram, right? Okay, let's read the scale, always read the scale. So 224 here would mean that this is 0.224. So remember, this is a decimal. Keep this in mind. This is distance. What was this? This is the length. So the length is measured in meters. So we have decimals. So keep that in mind. So they say find the median and the interquartile range. So we know what to do by now. So we need Q1, we need Q2, we need Q3. So we have how many, what is our sample size? 19. So we're going to say 19 divided by 4, right? So what is 19 divided by 4? I'll just say 19 divided by 4. I'm going to get 4.5. So I need the 50 value. So this is the 50 value. And then Q2 is going to be 19. Half of 19 is what? 9.5. 19 divided by 2 is 9.5, yes. So 19 divided by 2, tired brain, is equal to 9.5, which of course will be the 10th value. Remember, if you have a decimal, no matter the decimal, even if it's 9.0 something, 0.1, it doesn't matter. You take the next value as long as you have a decimal. Okay, so Q3 is going to be 3/4 of 19, which is 3 by 19 over 4. This will give me, so if I just say 3 times 19 equal to divided by 4 equal to, then I get 14.25, which is the 15th value. So I can conclude again that the median is equal to the 10th value for company A, machine A, not company A. I'm used to company A now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that would be 0.238. 0.238. And then my IQR is going to be equal to Q3 minus Q1. Q3 is the 15th value. So if this is 10, this is 11, 12, 13, 14, 15. So that's 0.245. 0.245 minus Q1 is the 5th value. That's 1, 2, 3, 4, 5, 0.231. 0.231. And I just plug this in my calculator. So what is 0.245 minus 0.231? That gives me 0.014. Okay, so you can just, since there's space, you can just write your answer where it's clear. So median equal to 0.238 meters. And then my IQR is equal to 0.014 meters. Okay, I'm done with that. Then we move on to the next question. Then they say it is given that for machine B, the median is this. Okay, so Q2 is this. The lower quartile, this is Q1, and the upper quartile, so this is Q3. Now, draw a box and whisker, or draw box and whisker plots for both machines, that is machine A and machine B. Remember, you're going to need all your data, Q0 and Q4, you can get from the stem and leaf. So decide where you're going to place the box and whiskers. So I want my company B here, machine, so this is a machine. So machine, I want machine A to be here, and I want machine B to be here. Okay, so make sure you label this. And then you want to decide on a sensible scale. So just make sure you decide on a sensible scale. So to decide on a sensible scale, we are going to go back, look at our data. It starts from 0.211, that is the least, going on to 0.256. Okay, so you want to decide on a scale here. So if you want to calculate, you can just calculate the difference between the maximum number and the least number, and then you divide by the major boxes so that you decide what the major box, what it should represent, what unit it should represent. So in this case, if I look at the data, I see that I can just start here from 0.210 and going on to 0. Let me just draw my line. Okay, so then I continue with my scale. This is going to be 0.22. So I say 0.220. And then here, maybe I have 0.230. I'll have 0.240. This will be 0.250. And then I have 0.260. And then I have 0.270. If you don't decide on a sensible scale, you are going to waste time. You are going to waste a lot of time on this question, trying to figure out what to do, whereas there isn't really a lot of marks. So machine A, what is the lowest value? The lowest value is, so 0.220 is my Q0 for A, 0.220, okay? Oh, so it's starting on this line, okay? And then for machine A, my Q1, I calculated it to be 0.231. So then I just place my 0.231 here. Once more, use a ruler. I advise you to use a pen so that the examiner can see what you're doing. The median is 0.238. 0.238. 0.238 will be here. All right, then we go on to the upper quartile. Upper quartile is 0.245. 0.245 is here. Then my largest value is 0.254. Okay, so I'll just place 0.254 is here. Right, so then connect Q4 and Q3, then connect Q1, Q0, and then draw your box. Then you're done with the box and whisker. Use a ruler. Then I go on to machine B. Machine B, the lowest value is 0.211. 0.211. So I wanted to have it there, so I'll say 0.211 will be here. And then I want my Q1 is given as 0.224. 0.224 is here. Then I need my median, which is 0.232. 0.232, 0.232. Then I need my Q3, which is 0.243. 0.243 is here. Then Q4 you get from the stem and leaf, that will be 0.256, 0.256. So we need 0.256, which will be right here. And then once again, connect Q3 and Q4, connect Q0 and Q1, and then just draw a box. Okay, so we are done. And then we go to the final question. This is the final question, I guess. Yes, it is. It says, hence make two comparisons. So this is two. So whenever this makes say make two comparisons, I'm looking to make one on measure of centrality, one on measure of spread. So the medians, if I look at the medians, you can see that machine A produces longer rods. So I'll say on average, machine A produces longer rods. Yeah, than machine B. You can say than machine B, but we know you are comparing to machine B. So than machine B. And then you can make another comparison. The other comparison is about the spread. Machine B is not as consistent. It's not as consistent as machine A. Okay, so we are done.